All right, so let's look at part B. Part B said, using the given differential equation, determine whether the graph of f could resemble this following graph. Give a reason for your answer. And so I'm going to talk about the first way to talk about it and then use some examples. Some people said, and I did award them credit, but we need to talk about why they might not be awarded credit on the test. So we need to use the derivative. And when I think about the values of this derivative, if I plug in y squared, right, this number is always going to be positive. So some positive number. And when I take a positive number and multiply it by a negative number, it will always be a negative value. So this is just a one-point problem, and what we needed to say is dy dt will always be negative. So f of t will always be decreasing. So this graph cannot represent f. Represent f, sorry. Okay, this graph cannot represent f because it has an increasing interval. Now, a lot of people said because the derivative is quadratic, the original function has to be cubic, and this is not cubic. So let's be clear. We are only looking at a little piece of this graph. Perhaps something like this happens. Now, it doesn't, and I think you guys would maybe know that it probably couldn't because, I don't know, it's not going to go up and back down. But just be clear that, yes, the antiderivative is a cubic function, but we don't know that just this piece they gave us isn't a piece of a cubic function. So think about that. I awarded because it was good justification, but it's not proof. The only proof we could use is something that's always true no matter what we see. The derivative is always negative, so the graph should always be decreasing.